In the last video we introduced the concept of terms and expressions, and in this unit we are looking at how we can write our expressions as neatly and as compactly as possible. So normally we like to write our expressions in the simplest possible way, which is why we learn to simplify them. So there's a couple of rules of simplifying. The first is that only like terms can be added or subtracted. So we're going to look at an example and then have a look at which terms are like each other. If they're like each other, then we can add or subtract them. If they're unlike, then we're not able to do anything to simplify them by adding or subtracting. And the definition of a like term is one which contains the same letters with the same powers. So, for example, if we have a look on the like column, here I've got x with no power, so it would be to the power of 1 if we were writing a power, and x to the power of 1. So here those two are like, they're both just involving x. Here you've got the same letters, you've got AB over here and AB over here, so those two are like each other. Here you've got two numbers can be simplified in exactly the normal way as we do our normal calculations, and here you've got x to the power of 2 and y, x to the power of 2 and y. So in all of these cases we could simplify them. Let's look at some unlike examples. So here I've got a number and an x. I can't do anything with that by adding or subtracting them. I need to keep them separate. Again, here I've got an expression involving just a, and here an a squared. The powers are different, so I can't do anything to simplify those two. Looking at my third example, I've got here, I've got an xy, and here a y. It's not the same combination of letters. This would have had to have been an xy if I wanted to be able to simplify it. And here, although I've got the same combination of letters, a and b, the powers are different, so I can't then simplify those. Can you just pause the video and take down this list of examples of like and unlike terms? So we've now got an example where I'm asked to simplify an expression containing 1, 2, 3, 4, 5, 6 terms. And before we do anything, let's think about what terms like each other. So here I've got my 2x term. Now that's not like this number term, it's not like an x squared term, but it is like my minus 7x. So what I'm going to do is just draw a little triangle around it. Now notice, when I draw my triangle around it, I'm also including the sign in front. Okay, so let's just put a little note to ourselves. The term includes the plus or the minus sign in front. Now the first term doesn't normally have a sign in front, which means it's positive, so I can just write it positive in there. Okay, so that's my x's term, so I can simplify that. I've got positive 2 and negative 7, so I'm starting at plus 2 in my number line. Let's just draw a little number line here if we need it. There's my 0. I'm starting at positive 2. This is where I start, and I'm going down by 7. Go down 1, 2, 3, 4, 5, 6, 7. It's going to give me minus 5. So positive 2x minus 7x is going to give me my minus 5x. So I'm going to just put that in. I'm going to put that in my blue triangle. Just to show that I've dealt with my x terms. Okay, let's now have a look at my minus 5 term. Well, obviously that's not connected to my x squared term here or here, but it is like my plus 2 term. So over here I'm going to put a little red box around my minus 5 and around my plus 2. And again, looking at my number line, if I started with minus 5, went up by 2, 1, 2, I'd end up with minus 3. So here minus 5 plus 2 gives me minus 3. And that's the result of simplifying the terms in the red boxes. The last one, I've got my plus 3x squared and minus 4x squared. I'm just going to surround those by a cloud. into a green cloud, plus 3x squared, and minus 4x squared. I start at positive 3, and go down by 4, to over here. There's my 0, start at positive 3, go down by 4, 1, 2, 3, 4, it's going to take me down to minus 1. So here, that's going to give me minus 1x squared. Now normally, we don't need to write in that 1, so I could just put minus x squared there. Now notice the other thing, common mistake here, is that people would have said, oh, I need to do something with these powers, so I've got an x squared and a minus x squared if I give me x to the power of 0. When you're adding and subtracting, when you're simplifying here, you leave the powers alone. Do not change the powers. When we're adding or subtracting. So the powers of x squared here and x squared here result in an x squared over here. I'm just going to can you pause the video now to make sure you've got that worked example complete and that you understand how we got it. Notice that you could have written these in any order you wanted. You could have minus x squared, minus 3, minus 5x. You can move these three shapes around however you want. It doesn't matter which order they come in. Okay, I'm now going to set you 10 questions to try yourselves. Please pause the video while you write these down and have a go yourselves before attempting the solutions. Okay, so here are the solutions to the questions. Do you want to pause the video and just correct your work with a green pen if you can? We're going to just look at a couple of questions where there are common errors. The first one's number 4, where we have a look at, we've got our minus 4q and a minus 5q. Now remember, we start off with minus 4. There's my 0. Start off with minus 4. And this tells me to go down by 5. 1, 2, 3, 4, 5. Down by 5 will give me minus 9, which is where my minus 9q comes from. The second one that people likely to have had some difficulty with was number 5. Looking here, we've got 3 different types of terms. We've got v term, we've got w term, we've got number term. So the only one that I can simplify is my 6v and minus 9v to give me minus 3v. The rest just stay the same. Just be really careful when you're marking in question 7 particularly. You've got your powers here, x squared, x squared, x squared. Notice that you've got your x squared here, so just make sure that that is an x squared and that you haven't added to those powers. Give yourself a mark out of 10 please, and if you had any difficulty on this, please go and have a look at Haggerty Clips 157.